Hey guys, welcome. In this video, we will try to understand pins, ports, and interfaces. There is a big confusion among all of us regarding these three terms because they are used in different ways in different fields. So our main goal is basically to understand these terms in VLSI design, but we will also look into other fields and how they are called in those fields, as well as the general understanding. First of all, let's understand what's a general understanding of what is a pin and what is a port in layman's terms. So a pin is usually called it's a single input or output of any device. Okay, and also a port, we say port is usually a collection of similar pins. So in the combination of pins is basically of similar type. Let's say those pins have same functionality, so if it is a collection, we usually call it as a port. So we have generally examples such as you see a cable, it's called as a VGA control, a VGA port. Also HDMI and VGA, I hope you understand what it is. And also a microcontroller, I have shown it here. You see that this is basically called a port. It's called a serial port, right? So it has its own pins. These are individual pins of this port. So this is our basic understanding, that it's a kind of a socket that we can connect it to some device or something through which the communication happens between the devices, right? So that's our basic understanding of pin and port. So for a pin, we say it is a single one. For a port, we say it is a collection of pins. So also the interface. Interface is a general term which is used to represent that it is a docking point using which the external devices can be connected to the device or the computer or anything. But in some cases, it's also called as collection of port itself. Okay, in very few cases, interfaces are also called as collection of ports. So this is our basic understanding. But this is not only related to hardware, it's also related to networking and programming and software as well. We will see that. So in networking and programming, that too in hardware networking devices, it is almost the same general understanding that the pin is a single pin and a port is a collection of pins through which we can connect another device or connect the computer to something else. But there are software ports as well for a computer or any device. Um, those are actually non-physical, through which the data flows from one computer to another computer or another to the internet also. So how does that communication happen? That is through the software port. So there are multiple examples. Actually, if you consider modern day computer, it will have somewhere around 65,536 ports actually, but out of which 1020 0 to 1023 ports are actually already assigned ones. They are assigned to particular tasks. On top of that, you have unassigned ones, but we will not focus on all that. We will just go and see what's the understanding in VLSI basically. And also in programming, there is the word interface is usually used for a technique that a class is used as a blueprint for um, as a interface where it is used for abstraction basically. So in VLSI we will try to understand how it works. In VLSI also there are two fields itself where these are treated much different ways. Okay, so first one is the VLSI design, or during the RTL design where HDL is used, Verilog or VHDL. In that case, pin is basically an input or output of a cell or a device. Now, I am not saying a single or multiple. It's just we are saying that input or output of a cell or a device. Okay. And next one is port. Port is what? Input or output of a design. Okay. Or terminals of module. If you consider the syntax of a module will be named something like this module, and its name we provide it, and all the data that you provide it to that um, to that module is basically the inputs or outputs. Those are all, even it is single or it is multiple, those are all treated as ports, not pins. Okay, this is because it is a design. This is design in the sense we know everything about that design. Okay, that's the design under consideration. So it's this pin term is very less that it is used in this design. Okay, only when this hierarchy is connected to this cell is instantiated in some other hierarchy, maybe in that case we can call these as pins. So we will understand, so it is very less in case of a VLS, in case of a in case of a Verilog code or somewhere you mention something as a pin, it's very less. So it's mostly we will call them as ports. So we will understand in physical design, there are two ways in which we can usually mention them, pins and ports. I still don't want you to get confused. Okay, why am I saying this is because I want to include all the types of ways where these are called differently. So if you consider a flat design, for a flat design based on the location of the interface, it is named. Okay, sometimes this is not standard, but sometimes it is named like this. um, so what do I mean by flat design? That means I don't have any hierarchies inside. That means that's what I meant. But it need not be always for that case. But I'm saying the design under consideration is a flat design. Okay. In that case, what happens? If we are if this hierarchy, if we are providing interfaces to the edge of it, at the boundary, at this boundary, if we are providing, we usually call it as pins. And if they are not actually related to each other, okay, we usually call it as pins, since this is our design under consideration. And all the other interfaces that we provide to the upper hierarchy, maybe we call these as ports. Okay, so these are basically ports because these are given to the upper hierarchy in the middle of the design, whereas these are provided the boundary of the design. But this need not be true always. This is not that standard, but it is also used. But more standard is this. Okay, so let's say this design is instantiated over here. In this case, what happens? You see that I told that these are called ports in the design. Let's say this is a standard cell. Okay, in standard cell there could be like multiple pins, right, for a single standard cell. If it has standard, when the standard cell designer, when he is designing, what he calls them as is actually port. Okay, he calls those as port because for him that is the design under consideration, so he calls them as ports. But the upper hierarchy designer, maybe a physical designer, where he instantiates thousands of these standard cells and he connects them to other nets. At that time, he treats this as pins. Okay, he won't treat these as a port. He will call, for him, what are the ports? The pins that he will expose to the top layer. Okay, this is some kind of an abstraction. This is used as an abstraction for to the top level. So you may say I have designed a block and I have given ports to my full chip, and full chip people will say, okay, these are the pins of the device. I hope you got some idea about what is a pin and a port and interface, and how they are actually called in different fields and different design levels differently. Thanks a lot for watching. I'll see you in the next video, and bye bye.